many years ago, more than a couple decades ago, when I was learning about Cisco routing and how it operated, I learned about something called PBR, which stands for policy-based routing. And it's fascinating. This router, for example, router 2, when it gets a packet, it normally looks at its routing table, makes a forwarding decision, and forwards it on its way. However, if we set up a policy using policy-based routing, we can tell the router to make conditional exceptions. For example, if the packet is coming from a certain source address or has certain characteristics, go ahead and respond in a unique or a different way than you normally would based on the policy. Well, one of the big features in Windows 2016 Server's implementation of DNS is the ability to use policy based on DNS. So instead of the DNS server simply responding to queries as normal, we can set up conditions and have the DNS server respond in special ways. In fact, earlier in this course, we did an example of a DNS policy when we told the DNS server not to just globally allow recursive DNS requests, but to only allow them if they were received on a specific interface of the DNS server. And in DNS, some of the conditions that we could look for or check for would be things like, what is the client subnet that the request is coming from? Or what interface on the server did this request come in on? We can specify the transport protocols that need to be present, or specifying if it's IPv4 based or IPv6 based. We can specify the type of record that's being requested. For example, are they looking for an SRV record or an A record or an MX record? We could also make it time-based, so that based on the time of day. In the morning, for example, it's one IP address that's going to be answered back as a DNS response, and during a different later portion of the day, it would be a different IP address. So these would be examples of criteria that we could then look for, and then based on them being present, have some type of action. And regarding the actions that we could specify, if we matched on those criteria, we could do things like allow, or deny, or ignore. And the question may come up, well, Keith, what is the difference between denying a DNS request and ignoring a DNS request? And the answer is, with the deny, we're going to give a nastygram, a message back to a client saying, sorry, not going to do this for you. Where with an ignore, we're simply going to be silent. We're not going to give any type of response back to the client. And with policies, we can either have them enabled, which means they're in force, or disabled, meaning they're not in force. Also, DNS policies can be placed either on the entire server. For example, we could apply it to server 1 right here, or we could apply it just to a specific zone. So applying it to the server would be a server-based DNS policy. And if we apply it to a specific zone, it would be, you got it, a DNS zone-based policy. And there could be multiple policies. Let's say, for example, on this server, we have 5 policies. And let's say they're numbered 1, 2, 3, 4, and 5. Well, they're processed in that order from the lower number going higher. So a lower numbered policy is going to be processed first. And then when there's a match, it's going to go ahead and execute that action, whether it's allow or deny or ignore, and then we're done. It's off to the next query. Now, another question that can come up is, what if we have a server-based DNS policy and also a zone-based DNS policy, and they don't have the same actions? Who wins? And the answer is the server-based policies are checked first, and then zone-based policies second. And again, once there's a match, the first match wins. Now, what'll be fun for you and I to do is let's go ahead and implement a policy. And part of the benefit of doing a DNS policy for load balancing is that we can specify weight values. So if we have a specific host or multiple hosts where we want to hand out those IP addresses more than others, this would be a great example of how to do that in DNS. And to demonstrate this, let's go ahead and create a new zone. And we'll call that zone loadbalancing.com. Just so when we see that zone in the lab, we'll think, oh yeah, that's the zone we created for doing load balancing. Now in that zone, of course, we're going to have records. We're going to have a start of authority record. We're going to have at least one name server record starting off on the server that we install this on. And if we want to have any A records, we need to create those as well. So in this zone, let's create an A record called lb-www. So the fully qualified domain name would be lb-www.loadbalancing.com. And in a previous nugget, when we looked at round robin, we had 3 A records. They had the same exact name. The round robin feature was enabled by default, and the DNS server just handed them out in different orders every time. But if we wanted to have policy-based load balancing, where we can actually do weights and control the actual responses, instead of just creating 3 records with the same name, we can go ahead and create additional scopes within that zone. Now, a scope is simply a subset of records inside of a zone. And I'll put the scopes in blue. Let's create a scope right here and another scope right here. And I'm also going to do this as well because by default, every zone has a default scope which matches the zone name. So even if we don't go in and manually create a scope, if we create the zone called loadbalancing.com, there is a default scope called loadbalancing.com. So in this zone, we get the default scope called loadbalancing.com for free. All the records go in there by default unless we take specific action to put them in a different scope. And what we could do is we could create two other scopes for this example. Let's create an additional scope called scope-light in the loadbalancing.com zone. Let's also create another scope called scope heavy in the loadbalancing.com zone. So at the end of the day, we'll have three scopes. We'll have the default loadbalancing.com scope, we'll have a scope-light and a scope-heavy. And then we can create additional records and put them into the appropriate scope. If we don't specify a scope, it's going to go into the scope called loadbalancing.com. If we create another A record and we specify we want it to go into scope light, let's go ahead and do that here. We'd have lb-www in scope light. And if we did the same thing for scope heavy, we'd have yet another A record, and I'm going to use the same name intentionally here, in scope heavy. And that way, when Bob, the user, makes a request over to the DNS server, the DNS server can look at policy and say, okay, what am I supposed to do? And in our policy, we could assign weights. For example, we could assign a weight value to the default scope in our loadbalancing.com zone. We could assign that one a weight of 1. And for scope light, we could assign that scope a weight of 1. And for scope heavy, maybe we give it a weight of 9. So once we create the scopes, put those records in those scopes, and then apply that DNS policy, the DNS server is going to respond with those records based on policy. So effectively, for scope heavy, we have a 9, and if we look at the other scopes, which we have a total weight of 2, we have a 9-to-2 ratio. So as Bob and other users do request regarding this zone information in that host record, out of 11 requests that were made, I'm just doing the quick math here, 9 and 2 more would make 11. 9 of those responses are going to be coming from the heavy scope, and approximately 1 would be coming in from the light scope, and another one from the loadbalancing.com scope. So what we'll do in the demonstration is exactly this. We'll create a new zone, we'll create 2 new scopes, we'll add a single host record to each of those scopes, and then we'll create a policy that gives the heavy scope a weighting of 9, and the default scope and the light scope a weighting of 1. And then we'll test the results. So let's log on to our client-nug machine. And once logged on, let's go ahead and open up the integrated scripting environment. And let's also do a Control-Shift-R and open up a tab over to DC-nug. Once there, let's also click on View and open up a scripting pane for that. And I'm also going to type in CD / press Enter here and do a CLS just to give us as much real estate as possible. And because on this one there is quite a bit of typing involved, I do have saved for you, my friend, in this lab environment, the scripts ready to go. And to open them up with the DC-nug selected, just click on the little folder for Open, or you can do a file open either way. It's going to put you in the temp folder, and you can just double click on 17LB server, and that will bring in the commands. And then you can go back to the original tab for DC-nug and just close it because we're not going to be using that. And for the local computer, I also have some scripts there as well. If we click on PowerShell 1 on the left-hand side and click on the icon for Open, if you double click on the 17-LB client, there's some client commands to get you started as well. So I'm going to go ahead and select untitled.ps1 and close that just to clean it up a little bit. So I've got the PowerShell for the local client on the left and the tab for DC-nug on the right. So even though these are really convenient to have right here, I would also encourage you to manually do this, to get really comfortable with the commands, because the more you practice with the PowerShell commands, the more comfortable you'll be with them. So row number 1 here, we've seen this command before. We're simply adding a new forward lookup zone, and we're calling it loadbalance.com. Nothing new here. We'll press F8 to launch that. On to row 2. Now row 2 is a new command. Add DNS server zone scope space -zone name, and then in quotes the zone where this scope will be created, and then -name, the name of that scope, also in quotes. So effectively we're creating this scope, this subset, if you will, of the loadbalance.com domain that's called scope-heavy. So we'll highlight that and press F8 to execute that. We're going to do the same thing with line 3. We're creating another scope called scope-light in the zone called loadbalance.com. So with row 3 highlighted, we'll press F8 to execute that. And in row 4, we're just going to swap out the add with get to do a get-DNS server zone scope -zone namespace, and then in quotes the name of our zone. So with that highlighted, we'll press F8 to execute that. And the reason I wanted you to see that is because I want you to see that we do have a default scope that matches our zone name of loadbalance.com. So we've got 3 scopes, 2 that we manually just created and 1 we got for free when we created the zone. Okay, with that done, let me go ahead and use the squeegee to clear off the bottom portion, and let's go to row number 5. In row number 5, we're just creating an A record. With the command add-DNS server resource record, we're specifying the zone where we want to put this. We're specifying the type of record, the name of that host, and its IPv4 address, which is 192.168.1.11. And that's just creating an A record. Now, the next piece is row number 6. We're going to add a DNS server resource record. It's also going into loadbalance.com. It's also an A record. Its name is also lb-www, but check this out. If we scroll to the right just a little bit, what we're doing is we're tacking on the scope that we're going to add it to. So this new A record with the host ending in .22 is going to be associated with the scope called scope-light. And if we look at line 7, we're adding yet another host record. This one ends in .33, and this one's going to go in our scope that we just recently created called scope-heavy. Just like that. So I'm going to go ahead and scroll all the way up back to the left, and let me add those 3 A records by highlighting row 5, 6, and 7, and then pressing F8 to add those 3. And the cool thing about this here also is you can see the full command right here in the output below. So we've created some scopes, we've added some A records to our individual scopes, and now it's time to set up our DNS query resolution policy regarding how the DNS server should respond when people ask for that record of lb-www.loadbalance.com. And here's that policy in row number 9. And the command is add-DNS server query resolution policy space -name, the name of the policy that you want to create, -action, the action you want to set up, for example, allow or deny, -fqdn for fully qualified domain name, and in quotes I'm putting equal, comma, asterisk, which means we don't care what the actual name we're looking up is. So that's the conditions that we're setting up on what we want to match on. If we wanted to be very specific to this host, we could actually put in the actual host name of lb-www.loadbalance.com, and that would work as well. In this case, everything in the zone is up for grabs. And then as we continue the command, let me go ahead and scroll right. The command continues -zone scope, and here's where we are implementing our weights. It's saying loadbalance.com, that scope, which is the default scope we got when we created the zone, we want the weight to be a 1. So it's loadbalance.com, comma 1. And then a semicolon, and then the name of our next scope, scope-light, also a weight of 1 with a comma 1, and then a semicolon, and then scope-heavy, comma 9. And that gives us the 2:9 ratio, or I guess we could also say it's a 1:1:9 ratio, regarding how this DNS server is going to respond when clients ask for lb-www.loadbalance.com. And then we've associated this policy with the zone name loadbalance.com. So it's not a server-based policy, it's a zone-based policy. And so we'll go ahead and execute that. I'm going to scroll all the way to the left to make sure that row number 9 is highlighted and press F8 to execute it. And it is done. We can use the command here on row 10, get DNS server query resolution policy -zone name space, and then in quotes the name of our zone. And with that highlighted, we'll press F8. And here it's showing us our LB policy. There's our processing order. So if there's multiple policies, they're processed in order. And when there's a match, it responds, and we're done. And this currently shows that the policy is enabled, and the action, when this policy is matched, is allow. It'll also do the load balancing based on the weighting of each of the scopes in that zone. Also, while we're right here, because there are so many PowerShell commands, I wanted to remind you of a method that we could use to discover additional commands. One of the options that we've talked about previously, it's worth bringing up again, is to click on View in the integrated scripting environment, and then from the drop-down selecting Show Command Add-on, and then giving it just a moment, and over on the right, it'll pop up the actual command window so you can build your commands step by step. So in our modules, we could go ahead and click that and type in DNS, and then from the list, select DNS server, and then from the commands, we could go ahead and start typing the commands that we want more specifics on. So this is the one that we're doing right here. We added a DNS server query resolution policy, and then we did a get DNS server query resolution policy. We can also use get-command. Here we have an *DNS server *, which says, hey, give me any commands that have -DNS server in it. And if we hit F8 to execute that, that's another way to see what many of our options are regarding DNS server related PowerShell commands. And one of those commands in the DNS server family is get-DNS server, which is row number 13. If we execute that and wait for a few moments, it's going to give us a boatload of output regarding our DNS server. And it's worth your time to practice with these commands, take a look at the output, and become more familiar with the options. For example, as part of the server settings for the DNS server, we have a socket pool size. And the reason it's set for 6783 is because that's what we set it for in a previous nugget. And it shows us that we have a server policy for recursion, which we've configured previously, and we have a policy for loadbalance.com that we just created. I just realized we have not verified that this is working yet as far as the load balancing. So let's go to our client tab and verify that as well. So on the client, I've got a clear DNS client cache. We'll go ahead and highlight that and execute that with an F8. And also with commands like nslookup and resolve-DNS name, those are actually going out to the server, so our cache won't matter too much. It's actually when we use utilities like ping or use a browser when our client's looking at the cache to pull the cached information. So here, if we highlight row number 2 and we run nslookup for lb-www.loadbalance.com and hit the F8 key, it comes back and says it is .11. Okay, great. And here's what I think we had to do. Let's go ahead and play a little game, unless you're driving. If you're driving or operating heavy machinery, don't do this. But on your left hand, let's go ahead and count the number of responses that come back from .11 or .22. Those two represent the host records inside of our default scope of loadbalance.com and our other scope of scope-light, which both have a weight of 1. And then on the right hand, let's go ahead and count the number of times we get a response back that indicates it's .33, which is our only host in the scope-heavy scope. So I'm going to do this too. I'll keep a finger available to hit the F8 key. So we have 1 on the left hand. So we'll press F8, and that's coming back with 33. Right here is our response. So on the left hand we have 1, and on the right hand we have 1. So let me go ahead and hit F8 again. All right, so that's 33. That'll be 1 more for the right hand, and F8 again. And that is 1 more for the right hand, and F8 again, and 1 more for the right hand. Now the moment of truth, it should be flipping over pretty soon to either .11 or .22. We'll do F8 again. There's 33 again. So on the left hand we have 1, on the right hand we have 5, and I'm going to hit F8 one more time. There we go. There's 22, so that's on the left. And then if we hit F8 again, there's 33. That's 6 on the right, and F8 again. And there's another on the right, and F8 again. Another one on the right, and F8 again. Another one on the right, and F8 again. And there's 11, 1 on the left. Okay, so at this current ratio, it's about 3 to 9. 3 on the left from the first 2 zones with a weight of 1. 3 on the left hand, representing the first 2 scopes with a weight of 1, and 9 on the right hand. I just realized you don't have 9 fingers on your right hand. I was keeping tally on paper. Or if you got to 5 and you started over again, that's great as well. But that closely reflects that ratio that we had for the load balancing policy between our scope with a weight of 9 and the other 2 scopes that had a weight of 1 each. So I had a lot of fun in implementing this DNS-based load balancing policy on our Windows 2016 server. And now, my friend, it is your turn. Go ahead and launch the hands-on lab and practice not only the creation of a new zone and the 2 new scopes and putting A records in them, but also the practice in verifying that you're getting the results that you expected from our DNS-based policy for load balancing. So have some fun with that, and I'll see you, my friend, in the very next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.